Hi, today we are going to see about interference and system capacity. The interference and system capacity is a major limiting factor in the performance of cellular radio systems. It creates bottleneck in increasing capacity. During interference in voice channels, crosstalk occurs. Interference in control channels gives missed and blocked calls. Urban areas usually have more interference because of greater RF noise flows and more number of mobiles. The sources of interference are another mobile in the same cell, a call progress in the neighbor cell, other base stations operating in the same frequency band. Non-cellular systems leaks energy into the cellular frequency band. The two major cellular interference are co-channel interference and adjacent channel interference. Co-channel interference is mainly due to frequency reuse. The cells that use the same set of frequencies are called co-channels. The interference between signals from these cells is called co-channel interference. It cannot be controlled by increasing RF power. Rather, this will increase co-channel interference. To reduce co-channel interference, co-channel cells must be separated by a minimum distance. When the size of the cell is approximately the same, the co-channel interference is independent of the transmitted power. Co-channel interference is a function of radius of the cell and distance to the center of the nearest co-channel cell. Increasing the ratio Q equal to T by R, the interference is reduced. Q is called the co-channel reuse ratio. In this figure, the yellow cells use the same set of frequency channels and hence interference with each other. In the cellular systems, there are 6 first layer co-channels. For a hexagonal geometry, Q equal to D by R, which is equal to root 3n. A small value of Q provides large capacity. A large value of Q improves the transmission quality with smaller level of co-channel interference. A trade-off must be made between these two. Let I naught be the number of co-channel interfering cells. The signal to interference ratio for a mobile receiver can be expressed as S divided by summation of II. The limits extends to 1 to I naught. Interference power caused by the ith interfering co-channel cell base station is due to N is the path loss exponent, which ranges between 2 and 4. The average received power at a distance D from the transmitting antenna is approximated by PR equal to P naught into T by Dn power minus N. When the transmission power of each base station is equal, the SIR for a mobile can be approximated as the given equation. For considering the first layer of interfering cells, the signal to noise interference ratio changes like this. Example, here 7 cell cluster is used. For hexagonal geometry with 7 cell cluster, with the mobile unit being at a cell boundary, the signal to interference ratio for the worst case can be given in this equation. Activity. Adjacent channel interference. Adjacent channel interference occurs due to interference from adjacent in frequency to the desired signal. The imperfect receiver filters allows nearby frequencies to leak into the passband, creates adjacent channel interference. Due to this, performance degrades seriously due to near-far effect. The graph shows the adjacent channel interference. Adjacent channel interference can be minimized through careful filtering and channel assignment. Keep the frequency separation between each channel in a given cell as large as possible. A channel separation greater than 6 is needed to bring the adjacent channel interference to the acceptable level. Problem is server Problem is severe if the user of adjacent channel is close proximity, that is called as near far effect. The other transmitter captures the receiver of the subscriber. Also, when a mobile station closes to the base station, transmits on a channel close to the one being used by a weaker mobile. The BS faces difficulty in discriminating the desired mobile user from the bleed over of the adjacent mobile. The near far effect is for case 1 is shown in this figure. The mobile receiver is captured by the unintended unknown transmitter instead of the desired base station. In case 2, the base station faces difficulty in recognizing the actual mobile user when the adjacent channel bleed over is too high. Minimization of ACI, adjacent channel interference. Careful filtering is needed and better channel assignment strategy must be followed. Channel in a cell need not be adjacent. For channels within a cell, keep frequency separation as large as possible. Sequentially assigning cells the successive frequency channels. Also, secondary level of interference can be reduced by not assigning adjacent channels to neighboring cells. For tolerable adjacent channel interference, we either need to increase the frequency separation or reduce the passband bandwidth. Power control for reducing interference is to ensure each mobile transmits the smallest power necessary to maintain a good quality link on the reverse channel. That also improves battery life, increase SIR and solves the near far problem. The assessment question is given. Thank you.